Welcome to classwork 6.6, textbook section 5.1, part 2. We're going to continue our study of identities today, and this is actually the last section in the book before we review for our test. So let's get right to it. We're going to start with this one. Let's pick the left side. This is example 6 here. You could pick left or right. I'm just picking the left because that to me, I like the left side actually. You could pick the right side, doesn't matter. Now, what's interesting about this is it looks like there's not a lot you can do. And that's because there's actually really only one thing you can do. You have to multiply by what's called the conjugate. So the conjugate meaning instead of 1 plus cosine, you do 1 minus cosine. And first, I'll show you what that does, and then we'll talk about kind of why we do that. So at the top, let's multiply it out. That's going to be sine x times 1 minus cosine x. I'm going to leave it factored just to make it easier for us. And the bottom, you're going to FOIL that. That's just 1 minus cosine squared. Now the reason we do that is because of this right here. So everybody highlight that. That should be something you know. That is a Pythagorean identity. That is sine squared. The top is sine. And now we have times 1 minus cosine x. Now notice what happens. The signs cross out, and we're left with 1 minus cosine all over sine. And there it is. Box it, happy face. So again, this is called the conjugate method. So I'll put some notes in blue for you. Conjugate method. It's a very specific technique for a very specific type of question. What I do is I think about conditions. So the first condition you want to see is you want to see a 1 plus or minus cosine or a 1 plus or minus sine. If you see that, that's a clue it might work. The second clue is you have a fraction equaling a fraction. If both those conditions are met, it's very likely that you're going to need the conjugate method. Okay, so I'm just going to put this over here. That's just your notes for the conjugate method. And again, remember the conjugate. The conjugate simply refers to this idea. A plus B, the conjugate is going to be A minus B. Okay, so that's our first example. The next example, example 7, put a line for us right there. We're going to use a bunch of techniques here. Let's pick the left side. There's clearly more to work with here. I'll drop my equals. So hopefully we remember tan is sine over cosine. Let's grab that negative and pull it out. That's just plus sine all over 1 plus cosine. At this point, there are a lot of things you can do. What I recommend is clearing the complex fraction, meaning we want to multiply by the least or lowest common denominator. So use the LCD. So I want to multiply top and bottom by cosine x. And let's see what happens here. The top will become sine plus sine cosine. So notice how that did get rid of our fraction. And the bottom, I'll leave it as 1 plus cosine times cosine. And again, I'm going to leave it factored just because I think that'll save us some time. Look at the top, there's a common factor. Let's factor out the sine. 1 plus cosine. 1 plus cosine times cosine. And notice how we have the 1 plus cosines, they cancel. And we're left with our tangent. We're done. So this is our last example. We're going to look more closely at the Pythagorean identities. I want you to make a diagram similar to mine, so I'm going to put a big box around mine. So using this, I really want to highlight this idea in our notes. Recall from last time that the major one, sine squared plus cosine squared equals 1. that implies two other things. That implies that sine squared is equal to 1 minus cosine squared. It also implies that cosine squared is equal to 1 minus sine squared. Now notice how I have 6 more blanks there. So we got to figure out what goes in there. So to do that, we're going to grab our regular one. I'm going to put the underneath here, then erase it. Sine squared theta plus cosine squared theta. If that equals 1, let's manipulate it algebraically. Let's divide everything by sine squared, and let's see what happens. This is 1, that's cotan squared, and that is cosecant squared. So look at that, we have another identity to use. So I'm going to write that here in green. 1 plus cotan squared theta is equal to cosecant squared theta. Now we can manipulate it, so this should imply a few things. This should imply that 1 is equal to cosecant squared minus cotan squared, and cotan squared should equal cosecant squared theta minus 1. Now let's get the final one. I'm going to erase this, you should too. Instead of dividing by sine squared, let's divide by the other function we use a lot, cosine squared. Let's see what happens. Tan squared theta plus 1 is equal to secant squared theta. So there's our last one. So I'll do that in red. Tan squared theta plus 1 is equal to secant squared theta. And in calculus, you'll use that one a lot later. So this should imply two things. This should imply that 1 is equal to secant squared minus tan squared theta. And it also implies that tan squared theta is equal to secant squared theta minus 1. So there we have it, the complete chart for Pythagorean identities. So now in these next two examples, we're going to practice using them. So you'll see that these are actually not too hard. For number 1, I'll pick the left side, there's clearly more to work with. I'll leave that as tangent for now. Look at that cosecant squared minus 1. I think we just talked about that. Look at your chart. That's equal to cotan squared. So cotan squared. And tan, well, that's the reciprocal of cotan. And look at that. That drops out. There's our answer, cotan theta. Number 2. So probably the left side is going to be a little bit easier. You could use the right side, but the left definitely has more to work with. You have to look at our chart and think, is there anything that we've learned? Do you see anything that we talked about in this problem? So I see a 1 plus cotan squared here. And look at our chart, that is actually an identity. So I'm going to write 1 plus tan squared theta all over 1 plus cotan squared is cosecant squared theta. Oh, we also see something else. 1 plus tan squared, look at that, let's highlight that too. That is equal to secant squared. And look at that, we're done. Take the reciprocal, sine squared over cosine squared, tan squared. Last one. This is the most challenging one. Definitely pick the left. Tan squared. So there are lots of things you could change tan squared into, but let's use the one we just worked with. Secant squared theta minus 1. You can see that right above the problem. That's all over secant theta plus 1 at the end. Hopefully you see it. Let's factor that top. Secant theta plus 1, secant theta minus 1. Divide that by secant theta plus 1. Cancel, cancel. The 1's cancel. And we have our answer, secant theta.